alkanes, hydrocarbons with only single bonds. Alkanes are also called saturated compounds. A saturated compound have the maximum amount of hydrogen bonds. They have only single bonds, they have no double and no triple bonds. Alkanes form a homologous series. What that means is the series of compounds have the same general formula and the same functional group. The functional group we're talking about here is alkanes. And then the general formula for alkanes is CnH2n plus 2. Alkanes is the most important source of fuel. So now we're moving on to IUPAC name giving. That means if you have a molecule, you want to give that molecule a name so that you and someone in China or someone in America can call the same molecule the same name. So for alkanes, the end of the name is -ane. And then you add in front of -ane a prefix which tells you how many carbon atoms there are in that molecule that you're talking about. So for prop, it means there is 3 carbons. And here's your table for learning what suffix or prefix is used for how many carbon atoms. Methane, 1 carbon. Pentane, 5 carbons. Octane, 8 carbons, and so forth. You can also have a branched alkane, which means you have an alkyl substituent. And this is indicated with the same prefix as before, but now it is a methyl for 1, ethyl for 2, propyl butyl. So, example 1. You want to give me the IUPAC name of this molecule. So we have certain steps to follow. Step 1. Identify the functional group. Functional group is alkane because there's only single bonds. Then you have to find the longest carbon chain, number the carbons, and check for branched groups. So, alkane, only single bonds. Number the carbons, 1, 2, 3. That CH3 is then a branch, and it is at carbon 2. So now the name would be 2-methyl propane. Methyl because there's only 1 carbon in the branched, and 2 because it is bonded to carbon 2. Propane because there's 1, 2, 3 carbons in the chain, and it is an alkane. Example 2. Draw the semi-structural and condensed formula for 2,2,4-trimethyl-hexane. So identify the functional group. This is an hexane, so you need 6 carbons with only single bonds. Find the longest carbon chain, number the carbons, and now the positions of the branched groups. You have a methyl group at carbon 2, 2, and 4. So, at carbon 2, there is a methyl group and another methyl group. At carbon 4, there is a methyl group. So, there's your structure. 1, 2, 3, 4, 5, 6 carbons, hexane, 2, 2, 4, trimethyl. But they asked for a semi-structural and condensed formula. Semi-structural means you do not show the hydrogen-carbon atoms. That's correct. So this is semi-structural and this is the condensed formula. In the condensed formula, you only show the groups. So here is your CH3. Then you have a carbon with 2 CH3 groups, carbon, 2 CH3 groups. Then you have a CH2, CH with a CH3 group, CH2, CH3. Example 3. Give the IUPAC name of this molecule. So, here you can't really see where the chain is and where the branches are. So, the easiest way to solve this problem is to draw the semi-structural formula. So, here is your semi-structural formula. CH3, CH3, CH, CH, CH3, CH2, CH, CH3, CH3. So, now you have to follow the steps. Identify the functional group. There's only single bonds, so it needs to be an alkane. Find the longest carbon chain. 1, 2, 3, 4, 5 carbons, therefore pentane. Number the carbons, and now you have to report the position of the substituents. There is a methyl at carbon 2 and a methyl at carbon 4. Therefore, your name would be 2,4 dimethyl, because there's 2, pentane. Example 4. Give the IUPAC name of this thing here. Your steps are: identify the functional group. Here is only single bonds, so it is a alkane. Find the longest carbon chain. Here it goes. Carbon, 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 carbon. Therefore, this CH3 here and this CH3 here are branches. Now you have to number the carbons. 1, 2, 3, 4. You have a methyl substituent at carbon 2 and a methyl substituent at carbon 4. So the name would be 2, 3 dimethyl butane. 1, 2, 3, 4 carbons. Example 5. Consider the organic compounds shown below. Which of the compounds above are structural isomers? Remember, structural isomers have the same amount of carbons and hydrogens. So you have to count the carbons and the hydrogens. 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4, 5. So it can only be 1 and 3 because they have the same amount of carbons. Example 6. A structural isomer of butane is propane, 2-methylbutane, 2-methylpropane, or 2,2-dimethylpropane. So, the easiest way to solve this problem is to draw these structures. Butane. It's got 1, 2, 3, 4 carbons. Propane, 1, 2, 3. 2-methylbutane. 1, 2, 3, 4 with a methyl substituent. 2-methylpropane. 1, 2, 3 with a methyl substituent. 2,2-dimethylpropane. 1, 2, 3 carbons with 2 methyl substituent. Remember, a structural isomer have the same amount of carbons and hydrogens. So butane's got 4 carbons. It cannot be A because there's only 3. It cannot be B because there is 1, 2, 3, 4, 5 carbons. It can be C because there is 1, 2, 3, 4 carbons. And answer D has got 5 carbons. Therefore, the correct answer is C. A structural isomer of butane is 2-methylpropane. Thank you.